A line creates a triangle with an area of 96 times square root of 3 square unit when it intersects the coordinate axis. Determine the equation of the line given that a perpendicular drawn from the origin to the line forms an angle of 30 degrees with the x-axis. Okay, let us begin. First, let's try to understand the problem graphically. For this, we are going to consider the xy coordinate plane. So here we have a line L. So let us assume that this line intersects the x-axis in the positive direction at the point A and the y-axis in the positive direction at B. Fine. And also what we'll do, we're going to consider a line which passes through the origin and it is perpendicular to this line. So let's say this is the line OC, and also it is such that it is making an angle of 30 degrees. So this is the angle 30 degrees that it makes with the y-axis. So using all of this information, our goal will be to find out the equation of the line, provided that the line L forms a triangle with the two axes, the x-axis and the o-axis, and that triangle has an area of 96 times square root of 3. Okay, let us begin. So first what we'll do, we're going to consider the equation of a line. So let us suppose that the equation of the line is given by x times cosine of angle alpha added to y times sine of angle alpha equals to p. So let's say this is the equation of the line. We're going to consider the normal form of the line. Now in this equation, we have to specify what's alpha and what is p. So here alpha is the angle made by OC with the x-axis. So that means this must be equals to angle alpha, and OC here the length of the perpendicular distance, that's p. Now here we can easily find out the value of alpha, because we know that since alpha plus 30 degree, they must sum up to give us 90 degree, which means that the value of alpha that must be equals to 60 degrees. So we now have the value of alpha, that is 60 degrees. Our next task will be to determine the value of the perpendicular distance p. So how shall we do that? So here we're going to use the fact that the area of the triangle is given to us. So area of the triangle, which is OAB, so it is given as 96 times square root of 3 square units. So this is given to us. Now what is the area of triangle OAB? We know that's simply given by half times the base. So here the base is going to be the x-intercept, which is OA, times the altitude. The altitude is simply going to be the y-intercept. So we have OB. We have half times OA times OB. So that's equals to 96 times square root of 3. So let's keep this aside for the time being. We're going to label this as equation number 1. Now what we'll do, we will try to figure out the value of O and OB in the next step. To do that, that's a very simple task. We take the lower triangle OAC and we take the upper triangle OBC. Since we have the angle alpha as well as we have the angle COB, which is 30 degree. So here we can use cosine of that angle in each of the two cases to find out the sides OA and OB respectively. So let's do that. So first we will consider the lower triangle. So let's say in the lower triangle OCA, so this is a triangle which is right angled at C. So here we have the angle AOC that's equals to 60 degrees. Now let's take the cosine of this angle. So what is cosine of 60 degree in this triangle? So here we know the cosine is the ratio of adjacent to that of the hypotenuse. The adjacent, that's going to be OC divided by the hypotenuse, so that's OA. So OC over OA, that is cosine of 60 degree. Now cosine of 60 degree, we know that it has a value of 1/2. So 1/2 becomes equals to OC. Now what is OC here? That is the perpendicular distance of P, where P over OA. So cross multiplying, we get OA equals to 2 times P. So let's label this as number 2. Next, what we'll do, we're going to consider the upper triangle. So we consider the triangle OCB, which is right angled at C, and we consider the angle BOC equals to 30 degrees. So again, we're going to take cosine of 30 degrees. So cosine of 30 degree is going to be equals to the adjacent length, which is OC, divided by the hypotenuse, so that's OB. Now cosine of 30 degree, we know that's square root of 3 over 2. So this is going to be equals to P OC, and that is P denoted by P divided by OB, which means that OB is going to be equals to So we have 2 times p divided by square root of 3. Let's label this as number 3. So what we'll do, we're now going to finally use the value of OA and OB, substitute this in equation number 1. So now equation number 1 implies, so we have half times OA, so OA, that's 2p, multiplied to OB, so that's 2p over square root of 3, and that is equals to 96 times square root of 3. Let's simplify. So we have 2p over 2, that's simply going to be p. P times 2p, that becomes us 2p squared divided by square root of 3 equals to 96 times square root of 3. So p squared is going to be equals to 96 multiplied to square root of 3 times square root of 3 whole divided by 2. So p squared, that's going to be equals to 144. So let's take the square root on both sides. So we're going to get plus or minus 12. So we have successfully obtained the value of p as well. So now what we'll do, we are going to substitute this back into our equation x cosine alpha plus y sine alpha equals to p, where alpha corresponds to 60 degrees and p is the value equals to 12. So we now have x cosine alpha plus, so now we have x cosine alpha plus y sine alpha equals to the perpendicular length p. So that is going to give us x times cosine of the angle 60 degrees added to y times sine of the angle 60 degrees, and that's going to be equals to 12. So we have x over 2 cosine 60 degrees, that's 1/2, added to y times sine 60 degrees, so that's square root of 3y over 2 equals to, this is actually plus or minus 12, not simply 12. We have to take both of the two values. Multiplying throughout with 2, we're going to get x plus square root of 3y equals to plus or minus 24. So these are the, we can say thus, x plus square root of 3y equals to plus or minus 24 are the required equations. So that means here we're getting two equations of line. So there's not only one equation, there are two equations of line possible. So let's go back to our figure. So that we have one more line which is going to be parallel to this line. So this is going to be the line which is going to be parallel to the other line. So let's call it L prime, such that if we consider this perpendicular distance, so this value comes out to be negative 12. So for the first quadrant value, we get OC equals to positive 12, and OC prime, that's going to be negative 12 here. So this is that's going to give us the equation of the other line.